So, good day everyone. Today we're going to discuss about the moment generating function of Poisson distribution. So, but before that, let's state first the definition of Poisson distribution. Poisson distribution, it is a discrete probability function. That means that the variance only takes specific values and given list of number, probably infinite. Then it also measures how many times an event is likely to occur within X period of time. So ang atong formula sa atong Poisson distribution is P of X is equal to E to the power of negative lambda, then lambda to the power of X over X factorial. Whereas ang atong E is the base of logarithm. Then ang atong X is a Poisson random variable. Then ang lambda is an average rate of value. So let's say for example, telephone calls arrive at an exchange according to the Poisson process. At the rate of lambda is equal to 2 per minute. Dayon, calculate the probability that exactly 2 calls will be received during each of the first 5 minutes of the hour. So ang atong given ani is x, which is ang atong Poisson random variable, is equal to 2. Then ang atong lambda, which is an average rate of value, is equal to 2. Then ato siya equal ng solution. So copy na to ang formula. P of x is equal to e to the power of negative lambda, then lambda to the power of x, then over x factorial. Then ato din siyang i-substitute. So copy the e, then to the power of negative 2, which is negative lambda man ang ato ipangita. Dayon 2 to the power of 2, which is ang atong x, is equal to 2. Then over 2 factorial, which is the x is equal to 2. Then ato siyang i-calculate. So mag-equal siya og ang e to the power of negative 2, then 2 to the power of 2 is ma-equal siya 0.541 over 2, which is 2 factorial is equal to 2. Then ato siyang i-divide, so ma-equal siya og 0.2705. Muna siya itong Poisson distribution.
Good day everyone, I am Rachel Abarabar, and to continue our reporting, let's proceed with its properties. So Poisson distribution has two following properties. Firstly, the mean of the distribution is equals to lambda, and its notation is a of x is equals to lambda, and this is it. The second one is the variance is also equal to lambda, which is var of x is equals to lambda. This is its formula. Now let's proceed to moment generating function of Poisson distribution. So we have this, the formula of Poisson or PMF of x. So, and this is the value of MGF of x, which is m sub x times t is equals to expected value of a to the power of t times x. And now the sum of all across x, a to the power of tx times p of x. And next one, we have the summation of x equals to 0 to infinity, which because Poisson start into 0, so that's why x is equals to 0, a to the power of tx. So now let's substitute the value of the formula in Poisson distribution. And then next, we will factor out a to negative lambda because it doesn't involve x. So the remaining in the other side is a to the power of t of x. A to the power of t times x times lambda to the power of x over x factorial. So that's the remaining. And then we will convert the numerator into power of. So this will be the answer will be a to the power of negative lambda summation of x equals to 0 to infinity lambda times a to the power of t to the power of x over x factorial. So now in this next step we will let a equals to lambda a to the power of t. So this will be, so now we have a to the power of x over x factorial. And as we all know, this part will equals to, let's see, this part is just equivalent to a to the power of a. So that's why it's become like this. And then in the next step, a to the power of negative lambda and times a to the power of lambda a t. So this is the value of a. So when we let a, this is its value. So that's why we have this notation, because a, we let a in the previous into lambda a to the power of t. So that is why naging ganyan na siya. For this next step, let's multiply the result. So here is the result of our multiplying in this step, and then so this will be the result, which is e to lambda a to t minus lambda. So we factor out lambda. That's why 1 na lang din siya diri, kay factor out man nato si lambda. So now let's get the first derivative of Poisson distribution. So for the first derivative, we will use the result in our previous derivation. So this is it, the result, right? So let's copy it here, and then we will get the derivative of this whole given, and this will be the result, lambda times e to t minus 1. And then next step, we'll multiply this part. So we will have lambda to e to t. This is the result. So at is lang sa to ang naa sa pikas. And the next step, we multiplied this result. So we have now a result of equal lambda 8 to lambda times a ti- a to t minus 1 plus t because kung mag-multiply man ta ang ato ang exponent ma-add ma plus raman siya so mo ni siya ang na-result sa atong exponent.
Good day everyone. I'm going to discuss to you the derivative of mean formula of Poisson distribution. So earlier we already get the first derivative of mx with respect to t, which we get this formula that ex equals to lambda e raised to lambda times e raised to t minus 1 plus t. Now we will going to let t equals to 0 to get the formula of mean of Poisson distribution. So this will become lambda e raised to lambda times e raised to 0 minus 1 plus 0 because we will all t will converted to 0. So equals to lambda e raised to lambda times 1 minus 1. So, why 1? Because e raised to 0 is equal to 1. So, this will also equal to lambda e raised to lambda times 0 or equal to lambda e raised to 0. So, since e raised to 0 equals to 1, so the expected mean or ex will become lambda. So, this is the mean formula of the Poisson distribution using the MGF. Next, we will going to solve the second derivative of mx with respect to t in order to get the variance of our Poisson distribution. So, second derivative of mx with respect to t equals to d over dt times first derivative of mx plus t. So, the first derivative of mx with respect to t equals to d over dt times lambda e raised to lambda times e raised to t minus 1 plus t. Then we will get the derivative of this. So it will become lambda e raised to lambda times e raised to t minus 1 plus t times the derivative of the exponent. So d over dt times lambda times e raised to t minus 1 plus t. Then we will just copy the first part. So lambda e raised to lambda times e raised to t plus minus 1 plus t times the derivative of the lambda e times e raised to t minus 1 plus t. So it will become the lambda e raised to t plus 1. So the derivative of t here is 1. So our ex squared is equal to lambda e raised to lambda times e raised to t minus 1 plus t times lambda e raised to t plus 1. So this is not yet the variance. So we will going to let t equals to 0 to get the variance of the Poisson distribution. So it will become lambda e raised to lambda times e raised to 0 minus 1 plus 0 times lambda e raised to 0 plus 1. So, since e raised to 0 equals 1, so it will become lambda e raised to lambda times 1 minus 1 times lambda plus 1. So, equals to lambda times lambda plus 1. So y equals to lambda plus 1 because it equals to lambda e raised to lambda 0. So times lambda plus 1. So since e raised to 0 equals to 1, so the remaining is the lambda, which gives us lambda times lambda plus 1. So we will going to distribute the lambda. So it will become lambda squared plus lambda. This lambda squared plus lambda is our ex squared. So to get the variance,
So the formula of variance equals to var x equals expected value of x squared minus expected value of x squared.
so the ex squared here is lambda plus lambda squared minus the ex squared, which is lambda squared. So we can cancel out this lambda squared and negative lambda squared. So the remaining is the lambda. So our var x is lambda. So the variance of the Poisson distribution using MGF is also the lambda. So in conclusion, the Poisson distribution is a way to predict the probability of the certain events happening in the fixed period of time or space. So the Poisson formula is Px equals to e raised to negative lambda times lambda raised to x equals to x factorial. Then the mean of our Poisson distribution is Ex equals to lambda. Same with the variance equals to var x equals to lambda. So the mean and variance of our Poisson distribution is equals to lambda. Now we leave you two exercises that you can practice at home. So hopefully you learn something from a lesson that you can apply in these two exercises. So that's all. Thank you for listening.